Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on integration using trigonometric substitution is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended to view the videos on integrals and trigonometry prior to watching this video. In this video, we will be discussing integrals of the form the square root of a squared minus x squared, the square root of x squared plus a squared, and the square root of x squared minus a squared. In each of these, a will be an integer. Integrals, where the integrand is of the form of the square root of a squared minus x squared, where a is an integer, may be solved using trigonometric substitution. If we construct a right triangle, with a as the hypotenuse and x on one side, then the length of the other side will be the square root of a squared minus x squared. We can then set one of the non-right angles as theta. This way we can relate theta to the sides of the triangle. In this case, sine theta equals x over a, or x equals a sine theta. Then dx would be a cosine theta d theta. Also, cosine theta would equal the square root of a squared minus x squared over a, or the square root of a squared minus x squared equals a cosine theta. Now we substitute the square root of a squared minus x squared with a cosine theta, and dx with a cosine theta d theta. This can be simplified to a squared times the integral of cosine squared theta d theta. In this example, let's find the integral of the square root of 9 minus x squared dx. This relates to the integral of the square root of a squared minus x squared, where a is 3. Recreating the right triangle, we see that sine theta equals x over 3, making x equal to 3 sine theta. Then dx is 3 cosine theta d theta. Cosine theta would be the square root of 9 minus x squared over 3, making the square root of 9 minus x squared equal to 3 cosine theta. We can now substitute in the integral the square root of 9 minus x squared with 3 cosine theta, and dx for 3 cosine theta d theta. When we simplify and remove the constant from the integral, we get 9 times the integral of cosine squared theta d theta. Next, we apply the identity cosine squared theta equals 1 plus cosine 2 theta over 2 d theta. The 1/2 can be moved outside the integral to get 9 over 2 times the integral of 1 plus cosine 2 theta d theta. Next, we take the integral to get 9 over 2 times the quantity of theta plus sine 2 theta over 2 plus c. We now distribute to get the 9 over 2 and replace the sine 2 theta with 2 times sine theta cosine theta based on the identity. Since the original integrand was a function of x dx, we need to replace theta. Going back to our triangle, sine theta equals x over 3, so theta equals arcsine of x over 3, so we can substitute that into our first term. In the second term, sine theta can be substituted for x over 3 and cosine theta for the square root of 9 minus x squared over 3. We then simplify for the final answer 9 over 2 times arcsine of x over 3 plus x times the square root of 9 minus x squared over 2 plus c. Integrals of the form the square root of x squared plus a squared may be solved in a similar manner. Again, remember that a represents an integer. In this case, we construct our right triangle so that x and a are the two shorter sides, which will make the hypotenuse the square root of x squared plus a squared. From this, we can derive tangent theta equals x over a, or x equals a tangent theta. Dx would then be a secant squared theta. Secant theta equals the square root of x squared plus a squared over a, or the square root of x squared plus a squared equals a secant theta. When we substitute, we get the integral of a secant theta times a secant squared theta d theta. Next, we move the constants out of the radical and combine our trig functions to get a squared times the integral of secant cubed theta d theta. As an example, let's solve the integral of dx over the square root of x squared plus 16. In this case, we construct a triangle with the a side equal 4, tangent theta equals x over 4, so x equals 4 tangent theta, which makes dx equal to 4 secant squared theta d theta. We can also derive secant theta as equal to the square root of x squared plus 16 over 4, which makes the square root of x squared plus 16 equal to 4 secant theta. When we substitute, we get the original integral of 4 secant squared theta over 4 secant theta d theta, which simplifies to the integral of secant theta d theta. We take the integral to get the natural log of the absolute value of tangent theta plus secant theta plus c. Referring back to our triangle, we substitute tangent theta for x over 4 and secant theta for the square root of x squared plus 16 over 4. When we simplify, we got our final answer, the natural log of the absolute value of x plus the square root of x squared plus 16 over 4 plus c. Integrals of the form the square root of x squared minus a squared may also be solved using substitution. In this case, we set one short side of the right triangle as a and the hypotenuse as x. This makes the other short side the square root of x squared minus a squared. From this, we can derive secant theta equals x over a, or x equals a secant theta, which makes dx equal to secant theta tangent theta d theta. We also derive tangent theta equals the square root of x squared minus a squared over a, or the square root of x squared minus a squared equals a tangent theta. So the integral of the square root of x squared minus a squared dx equals the integral of a tangent theta times secant theta times tangent theta d theta, or a times the integral of tangent squared theta secant theta d theta. In this example, we take the integral of the square root of x squared minus 1 over x dx. We construct our triangle making the a side equal to 1. When we set the angle theta, we can derive that secant theta equals x over 1 or x. This makes dx equal to secant theta tangent theta d theta. Tangent theta equals the square root of x squared minus 1 over 1. We'll also use cosine theta. Since we have an x in the denominator, cosine theta will equal 1 over x. Next, we substitute to get the integral of cosine theta times tangent theta times secant theta times tangent theta d theta. We can simplify cosine theta times secant theta equals 1, then combine the two remaining tangent thetas to get the simplified integral of tangent squared theta d theta. We can now use the identity tangent squared theta equals secant squared theta minus 1. Now we take the integral. The integral of secant squared theta d theta is tangent theta, and the integral of 1 d theta is theta. So we get tangent theta minus theta plus c. Referring back to our triangle, tangent theta equals the square root of x squared minus 1, and since secant theta equals x, theta will equal arcsecant of x. This gives us our final answer, the square root of x squared minus 1 minus arcsecant x plus c. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.